Good day, sir. I'm Estelle Dannicah W. Cobarde, and I'm the leader of Group 5. And I am here with my group mates, Ayah Semilla, Irish Mae Estenzo, Christian Agbon, Thomas Yuri Hamoy, Reena Maye Mata, Charmane Filoteo, and Nike Joy Sison. And we will be reporting about histograms today. Next slide, please. Next slide. For the table of contents, we will start off with the introduction, followed by the description, then the definition of terms, the procedures, the sample problems, then the solution, followed by the interpretation, conclusion, and lastly, the references. Now to start off, we have Ayah Semilla for the introduction.
So hello there, Ayah's here. And as we all know, summer season has finally begun. It's a season for warm weather, so we definitely need to drink lots of liquid like water to keep us hydrated. Though we have to admit that nothing beats Coca-Cola in quenching your thirst. Yet, did you know how much Coca-Cola's revenue is in a year? This graphical representation will allow us to track the Coca-Cola's revenue in 1 decade. Next slide, please. So as we can see here, they got their sales quite high around 2011. And though it went down the following years, but we can see that it's trying to be back on its track again. And now, through this graphical representation of the Coca-Cola's revenue, it will help the owner as well as the marketing heads in improving their product. But do you know what graphical representation is being used when tracking sales? How did it differ to bar graph? All these questions and more will be tackled in our discussion today. Now first, let us know the history of histogram. Next slide, please. Here. So the word histogram is of the Greek origin, composite of the words istos, which means must, and gramma, which means something written. Thus, it refers to writing involving of masts. So masts pertain to long shapes vertically standing. This was first coined by Carl Pearson in 1985. But it was said that it was first introduced in one of Pearson's statistics lectures in 1892 as a term for common graphical representation. The first use of bar graph for frequency distribution was by André Michel Yuri in 1830s with the purpose of displaying crime frequencies. Next slide, please. And as for its importance, we have here first, it helps visualizes continuous distribution of variables such as temperature, time, and weight. Also, it helps to evaluate the present state of a system, and it helps in setting goals or targets as well as stratifying data. Next slide, please. Histogram is also useful in identifying the, what do we call this one? Outliers. And then also it helps in determining the shapes of your distribution. Furthermore, it demonstrates the reoccurrence of variable within a specific range. And most importantly, it helps in confirming and comparing of results. Now, for more details, we have Ms. Estenzo.
Hi, my name is Mae Estenzo, and I'm going to talk about what is histogram. Histogram is defined as a type of bar chart that is used to represent statistical information by way of bars to show the frequency distribution of continuous data. It indicates the number of observations which lie in between the range of values known as the class or bin. It is divided into a continuous number range along the x-axis and y-axis. The horizontal or the x-axis display the number of range, while the vertical or the y-axis frequency represent the amount of data that is present in each range. The histogram is like the bar chart because it also composed of bars. Histogram visualize a quantitative data or the numerical data. It groups the number into ranges, while the bar chart display the categorical variables. As such, it's considered as one of the most straightforward method in visualizing distribution. Different types of distribution and histogram. Distribution type is normal, squid, double peak or bimodal, multimodal, edge peak, comb, heart cut, dog food. The histogram type is uniform, bimodal, symmetric, and probability. To discuss more about the definition of term of the histogram, we have Mr. Agbon.
Good day, everyone. My name is Christian Agbon, and I will report of definition of terms. Histogram, a graph of frequency distribution in which rectangles with bases on the horizontal axis that are given widths equal to the class intervals and heights equal to their corresponding frequency. Bar chart show the frequency counts of values for the different levels of a categorical of nominal variable. Relative frequency is the ratio of number of times and value of the data occurs in the set of all outcomes to the total numbers of outcomes. Frequency table lists a set of values and how often each of one appears. Continuous data represent the measurement and therefore their values can't be counted but they can be measured. Class, a groupings of value by which data is bind for computation of frequency distribution. Quantitative, data are measure of values or counts are expressed as numbers. Data distribution is the function of listening which show all the possible values or intervals of the data. Range is the difference between the largest smallest values. Frequency is the number of terms and value of data. Procedure, Mr. Hamoy.
So good day everyone, my name is Thomas Yuri Hamoy and today I am discussing the procedures of on how to make a histogram. Next slide please. So classes or bins, there are some preliminary steps we must take before making a histogram. The first step is to generate some basic summary statistics from our data set. Next is to compute for the range. The formula for computing range is maximum value minus minimum value equals range. So range is used to determine the width of our classes. So afterwards, divide the range by 5 for small data set and 20 for larger data sets. These numbers represent the width of a class or bin. This number may need to be rounded and or used with caution. After determining the class width, we select a class that contains the smallest data value. We then use our class width to create subsequent classes, stopping when we reach the maximum data value. So on the other hand, we have frequency tables. So after we've determined our classes, we'll create a table of the frequencies. Begin with a column listing the classes in ascending order. The following column should include a total for each of the classes. The third column represents the number of frequency of data in each class. The last column shows the relative frequency of each class. This indicates what percentage of the data falls into that category. So during the histogram, we have 6 steps. Yeah, so let's proceed. Next slide, please. So first step is to draw a horizontal line. This is where we will denote our classes. So as you can see at the table, the lowest line is the first step. So for the second step is to place evenly spaced marks along this line that correspond to the classes. Third step is to label the marks so that the scale is clear and given a name to the horizontal axis. Fourth is to choose a scale for the vertical axis that will accommodate the class with the highest frequency. You must take note that the vertical axis must have the highest frequency in order for us to create a histogram that accommodates all of the data. Next, please. Fifth is to label the marks so that the scale is clear and give a name to the vertical axis. And of course, you must construct bars for each class. The height of each bar should correspond to the frequency of the class at the base of the bar. We can also use relative frequencies for the heights of our bars. Next, we have sample problems. Miss Mata.
Good day, everyone. My name is Reena Mae Estenzo, and I will be introducing today's sample problems. Next slide, please. For the first problem, the histogram below shows the heights in inches distribution of 50 middle-aged women who are inpatients in the University of Cebu Medical Center. For the problem number 2, the histogram below shows the level of cholesterol of 350 UC College of Nursing students. For problem number 1, the first question asks how many people have heights between 4'11 and 5'1 inches. We have here Ms. Charmane Filoteo for the answers. The solutions.
Good day to everyone. So for the 4'11, we have 6 people. For the 5'1 inches, we have 9, and we need to add those 2. And for the answer and interpretation, we have Joy Sison.
So in question number 1, the people have heights between 4'11 and 5'1 are 15 people.
For question number 2, it asks how many people have heights less than 5'2 inches.
There are 4'11, 6 people for 4'11. We have 9 people for the 5, and we have 7 people for the 5'1. And we need to add those 3 to come up with the answer.
So the answer for the question number 2, the people have heights less than 5'2 inches are 22 people.
The third question asks how many people have heights more than 5'2 inches.
The heights more than 5'2 inches are 5'3", 5'4", and 5'5". For the 5'3", we have 5 people. 5'4", we have 2 people. And for the 5'5", we have 1 person. And we need, again, to add those 3 to come up with.
So the answer for question number 3, the people have heights more than 5'2 inches are 8 people.
For question number 4, it asks what percentage of people have heights between 5'2 and 5'3 inches.
People that has heights 5'2 are 5 people, and the 5'3 we have 2 people, and then we need to add those 2 7 and we need to divide them by 50 because there are 50 middle-aged women and inpatient women. So we need to add those and we came up with the answer.
So in question number 4, the percentage of people have heights between 5'2" and 5'3" inches is 0.14, and it will be multiplied by 100, so the percentage is 14%.
For the last question, it asks how many people have heights between 5'3" and 5'5" inches.
For the people who have heights with 5'3" are 2 people, and for the 5'5" we have 1 person, and we need to add those two to come up with.
So in question number 5, the people have heights between 5'3" and 5'5" are 3 people.
For problem number 2, we have here question number 1. So question number 1 asks how many people have a level of cholesterol between 100 and 140 milligrams per DL.
So for the 100 we have 0.05. For the 140 we have 0.1. We need to add those two and multiply by 350 because there are a total of 350 people. So we came up with the answer.
So in question number 1, problem number 2, the people have a level of cholesterol between 100 and 140 milligrams per deciliter are 52.5 or 53 people.
For question number 2, it asks how many people have a level of cholesterol less than 160 mg per DL.
For the less than 160, we have 100, 120, and 140. For the 100, we have 0.05. For the 120, we have 0.1. For the 140, we have 0.2. Add those three and multiply it by 350.
So in question number 2, the people have a level of cholesterol less than 160 milligrams per deciliter are 122.5 or 123 people.
Question number 3 asks what percentage of people have a level of cholesterol of more than 160 milligram per deciliter.
More than 160, we have 180, 200, and 220. For the 180, we have 0.35, 200, we have 0.25, and for the 220, we have 0.05. And add those three and multiply it by 100.
In question number 3, the percentage of people have a level of cholesterol of more than 160 milligram per deciliter is 0.65 times 100 is equals to 65%.
For question number 4, it asks how many people have a level of cholesterol between 120 and 180 mg per deciliter.
Between 120, we have 0.01. 140, we have 0.2. 160, we have 0.35. Add those three and multiply it by 350.
So again, in question number 4, the people have a level of cholesterol between 160 and 180 milligram per deciliter are 227.5 or 228 people.
For the last question of problem number 2, the question asks how many people have a level of cholesterol between 180 and 220 milligrams per deciliter.
So for 180, we have 0.25. 220, we have 0.5 and add those two and multiply it by 350.
For question number 5, the people have a level of cholesterol between 180 and 200 milligrams per deciliter, or 105 people.
So in conclusion, the word histogram was of Greek origin, and it is composed of the words istos, meaning mass, and gramma, meaning something written. So overall, this generally means writing involving of mass, which refers to long shapes, vertically standing or something similar. So the term histogram was first coined by the British statistician Karl Pearson in 1895, and it was first introduced in one of his lectures of statistics in 1892. However, the first use of bar graphs for frequency distribution was by Andre Michel Gary in 1830s to display prime frequencies. Next, please. So histograms have been very successful and useful within the database world. Its method of representation of data provides an optimal overview of data in an efficient manner. Not only is it efficient, it also promotes simplicity, effectiveness, and applicability in data approximation. Histograms are similar to bar graphs. Thus, oftentimes, people interchangeably use these terms as they both are visual interpretations. But more importantly, we can distinguish histogram from bar graphs so histograms represent frequency distribution and variables in data set, whereas a bar graph represents graphical comparison of discrete variables. Next slide, please. So creating a histogram provides a visual representation of data distribution, which can be used to display a large amount of data and frequency of the data values. The median and distribution of the data can be determined by a histogram. So to add, there are different types of distribution and histograms we can use. For example, for the distribution types, we have normal, skewed, double peaked or bimodal, plateau or multimodal, edge peak, combed, truncated, or what we call heart cut, and lastly, dog food distribution. As for the histogram types, we have a uniform histogram, bimodal, symmetric, and probability. Now, furthermore, we can consider that histogram is a handy way in identifying any gaps in the data, and it is an excellent tool for determining the shape of your distribution. It is also commonly used in statistics to demonstrate how many of a certain type of variable occurs within a specific range. That's all. Next slide, please. So now we have our references. Next slide, please. So below we have all our following references. And so once again, this is the end of our report. So thank you for listening, sir. We are once again Group 5 of BSN 1L, who was discussing about histograms. Thank you.